If you're watching this video, you are likely to be preparing a poster for a scientific conference. This could also mean that your conference abstract was accepted and that you have been invited to give a poster presentation. In this webinar, we highlight the visual attributes of the poster, the layout, the font size, the color schemes, but we will also talk about how we can put it together. By the end of this session, we hope you will be able to do the following: address the correct audience in your poster, write the major sections of your poster, use bulleted lists and graphics appropriately, and add titles, references, and acknowledgements to your poster. We begin by asking you to write and analyze a poster that was created based on the journal article by Vesely et al. Regarding aldehydes in beer. Journal articles usually include far too much information for a single poster. Hence, in this poster, I've included only a fraction of the information presented in the full journal article. Both the original article and the poster are on your Google Slides. The hypothetical poster focuses on what Vesely's group might have presented early in their research, specifically the methods that they developed to analyze their samples. A black and white version of the poster is available. I will guide you in the analysis of the poster later on, but spending adequate time answering the above questions regarding the expert lays the groundwork for the rest of the session. So please don't skip this part. Pause the video here and answer the questions in this task. There is no one right audience to target in a poster. Rather, the correct audience will vary with the conference. Some conferences are primarily for experts. Others, such as the National Meeting of the American Chemical Society, attract a wide range of individuals, from high school teachers and undergraduate students to research professors and other people that are interested in chemistry. Sometimes the title of the conference suggests the predominant audience. Most conferences send presenters a list of poster guidelines, and information about audiences is often addressed in those guidelines. If after reviewing the conference title and poster guidelines you are still unsure about the correct audience for the poster, it is best to target a specific audience, such as graduate students, faculty, or professionals who are in a different discipline or subfield of chemistry. Don't assume that most viewers will be knowledgeable about your research area. More than likely, only a few will have such specialized knowledge. Thus, prepare your poster for your most probable audience, that is chemists and chemistry students with a research emphasis different from yours. The poster text is divided into the same general IMRD sections as a journal article: introduction, methods, results, and discussion. Similarly, most posters include an acknowledgement section, some have an abbreviated reference section, and all have a title and author list. Most posters do not include an abstract, in part because of space limitations, and in part because an abstract already appears in the conference proceedings. Like the journal article, the IMRD structure of the poster follows an hourglass shape. The top and bottom sections have broader focus and scope, while the middle sections, the methods and the results, have a narrower focus. Each section of the poster can be divided into individual moves or steps that guide viewers in a conventional way through the content of each section. We will analyze these moves in the next few slides. The layout illustrated here is modeled after a newspaper. Thus, it should be familiar to most readers. The column format is used by the vast majority of authors. Columns make it easier for multiple viewers standing side by side to read your poster at once. The title, the authors and affiliations go across the top of the poster and can be left justified or centered. The sections of the poster begin in the upper left corner. The viewer reads one column, reaches the bottom and moves over to the next one, and so on. The text itself moves the reader's attention down the column, making the flow easy to follow. The number of columns varies with the size of the poster, but usually 3 are very, very typical. This design inevitably includes 2 rows. Typically, there is not enough space for more than 2. The advantage of this approach is that it allows 2 or more figures to be arranged side by side for easy comparison. However, this layout is difficult to follow visually, and it requires viewers to move from left to right twice for 2 rows as they read the poster, which is an inconvenience if the conference is crowded. For these reasons, most authors avoid the pure row layout and instead use the combined column and row approach. The poster methods section offers a brief snapshot of the methods used in the presented work. Of course, the methods section will be more involved if the poster focuses on the development of a new method or procedure. The essential moves of the methods section are presented in the excerpt that you will be looking at. First, materials and the methods are presented. The term materials is used loosely and refers to chemicals, solvents, standards, samples, and so forth. Similarly, the term methods refers to instrumentation, experimental methods, or even numerical procedures. Because materials and methods are rather specialized, this section targets a relatively narrow audience. Note that the moves shown here are characterized by the words highlight, summarize, identify. These words emphasize the importance of brevity in the poster method section. The average person will likely view your poster for only a few minutes. Complex experimental procedures are too difficult to grasp in such a short time. Instead, focus only on the key steps used to obtain the information presented in the poster. If more details are needed, viewers will ask you for them. Now it's time for a task. I want you to review the excerpt provided and based on it, answer the following questions. What information is generally included in the method sections of posters? What information is typically excluded? What conclusions can you draw about the audience that is targeted in the method section of a poster? How well does this poster follow the move structure shown in the previous slide? Pause the video here and do the task. Writing conventions typical of a poster method section are summarized below. Many of these conventions apply to other sections of the poster as well. Let's start with abbreviations. Abbreviations are usually defined in parentheses in their first use, for example. Readily understood symbols or abbreviations may be used without definition. For example, GC over MS. Everybody knows that. A few unconventional abbreviations may be used in posters if space is tight. For example, temp for temperature, RT for room temperature, WK for week, EXP for experiment, SATD for saturated, and so on. Additionally, some abbreviations, such as those for long chemical names, need not be defined if an exact identity is not essential for understanding the poster. Be careful, however, not to become too casual with abbreviations. For example, popular shorthand is not appropriate, like B4 for before and FYI for your information. Please avoid these. Also, use abbreviations consistently throughout the poster. For example, EQ should not be used for equation and equivalent in the same poster. Now let's move on to bulleted or numerical lists. Lists are common in posters. It is customary to capitalize the first letter of the first word in a bulleted list if the list contains full sentences ending with periods. Lowercase is preferred. When possible, use the same type of lists, bulleted or numbered, throughout your poster, as consistency is very, very important. When it comes to capitalization and with regards to molecular formulas, for example, sodium oxide, abbreviations or instrument venters and chemical compounds, all these are capitalized as recommended in the ACS style guide. Finally, we need to stick to the conventions regarding numbers and units as we know them already. Although conventional scientific units should be used in poster method sections, some formatting conventions may be relaxed. For example, the conventional space between a number and its unit may be omitted in a poster, and the numerical form of a number may be used instead of its word form, even at the start of a sentence. If space allows, however, follow conventional practices. One convention that should never be relaxed is the use of leading zeros for numbers. For example, use 0.35 and do not use 0.35. Let's move on to the results section. The results section is undoubtedly the most important section of the poster. The chance to share your results with others is the predominant reason for preparing your poster in the first place. However, you must be careful not to overwhelm your readers by presenting too many results. Focus on one or two key findings, targeting a reasonably narrow audience, hence the narrow part of the hourglass. Avoid the temptation to crowd too much information into a single poster. Limit yourself to results that can be digested in just a few minutes. Deciding which results to include and which to exclude is one of the most challenging steps in preparing a poster. Note that raw data, such as spreadsheet calculations, uncalibrated measurements, original spectra, before they have been baseline corrected, should not be included in a poster. It is important that you present results only after they've been carefully analyzed and prepared for public view. Most results in posters are presented in graphical form. Figures, graphs, photographs, schemes, illustrations, or spectra. Graphics are preferred over text because they allow the reader to comprehend the data more quickly, provided the authors do not overcrowd their graphics. The text accompanying the graphics serves largely to guide the viewers through the data. In general, figures are preferred over tables because they're easier to read and understand at a glance. However, tables may be included if they provide useful information or illustrate important trends. As you prepare your results section, imagine walking someone through your poster. Your results should be organized so that they guide viewers through your story of scientific discovery. Let's have a look. Let's talk a little bit about the moves that you see here. In move 1, you set the stage and prepare the viewers for moves 2 and 3 by presenting preliminary results, that is, results that lead toward your principal findings, which should be included in move 2. Preliminary results can introduce or motivate your claims. For example, you can talk about a spectrum that shows the presence of a pollutant. Or you can build confidence in your measurements by talking about a calibration curve, or lay groundwork needed to understand your principal findings, such as a chromatogram that illustrates how a complex mixture was separated. As you prepare move 1, imagine yourself pointing to your poster and saying to your viewers, first, we want to be sure we could do this. Or you can say things like, in previous work, we successfully prepared this or that. Yeah. And then by preparing your viewers for what lies ahead, you strengthen their confidence in themselves to understand your results and in you to present the data that they can trust. After the foundations are laid in move 1, you are ready to share principal findings in move 2. Using 2 to 4 graphics and accompanying text, focus your viewers' attention not only to the most important results. In posters, these results can report what has already succeeded or what has yet to succeed. Use graphics to display the trends visually and use text to highlight and summarize those trends. Label relevant peaks and features in your figures to draw your viewers' attention to the most important areas. These labels will make your key findings more conspicuous. As in journal articles, poster figures include captions placed either below or to the side of the figures. Unlike figures in journal articles, poster figures may also include titles above them. To summarize, as you prepare your results section, divide your results into 3 groups: preliminary results, principal results, and related results. Share preliminary results first, principal results second, and related results third. How you categorize your results, though, is your decision. What is important is the logical thread connecting all the data that you share. Now it's time for another task. I want you to review the excerpt provided and highlight all the sentences indicating move 1 in blue, move 2 in 3 in red, and move 3 in green. Pause the video here. As you can see, these results have been moved to a single bulleted item in the method section, which states simply that the fiber was placed in the sample headspace. In another result section, we see that the author focuses on the aldehydes. They use figures to convince the viewer that the aldehydes can be detected, a chromatogram showing their retention times, a mass spectrum of methionol, and so on. The principal findings are shared later on. In figure 3, a bar graph summarizes the concentration of 9 aldehydes after 4, 8, and 12 weeks of storage. The graph groups the aldehydes by their most likely source. This grouping will also be useful in the discussion section in the poster, where the individual aldehydes are discussed. The text accompanying the graph reinforces these trends, and the authors expand these results in figure 4. They explain the relationships between aldehyde concentrations and beer flavor thresholds. Based on based only on figure 3, a viewer might assume that one compound, furfural, affects beer flavor because it increased the most during beer storage. However, as shown in figure 4, even at high concentrations, this compound is only a small fraction of its flavor threshold. Instead, there is another compound, E2-nonenal, that has the greatest impact, although it is still 30% of its flavor threshold. Figure 4 also makes clear the important message that none of the aldehydes in stored beer exceeded their expected flavor thresholds. The writing conventions listed in this slide are commonly used in poster results sections. When it comes to abbreviations, due to limited space, you see the abbreviation FIG instead of figures, but table is not generally abbreviated. Other readily understood abbreviations may be used when we are tight for space. For example, temp for temperature, or compound names. When it comes to bulleted or numerical lists, again, they are frequently used, but we follow the formatting guidelines presented in the discussion of poster method sections. When possible, use the same type of formatting throughout your poster. When it comes to graphics and graphics labels, we follow the same formatting guidelines as journal articles. Two differences are that one, in titles, they might be used in poster figures. Two, color may be used freely in poster graphics. As in journal articles, poster graphics should be labeled. Table titles are placed above the table. Figure captions are placed either below or beside the figure. Dangling graphics, that is, graphics that are never referenced in the text, should be avoided. Exceptions to this rule are graphics added primarily for visual appeal, such as a logo, a photograph, or clip art. Now, when it comes to verb tense and voice, poster results sections use past tense to describe results obtained in the past and present tense to describe facts expected to be true over time. When it comes to voice and the use of we, poster results sections use both passive voice and active voice, but the word we is usually avoided. Say, for example, high sensitivity was achieved, and do not say we achieved high sensitivity. Say 5 factors were optimized, but do not say we optimized 5 factors. Now, in this task, I want you to consider the following sets of bulleted items, which are adapted from 3 different papers. And I want you to say which item is most appropriate for a poster results section. I want you to consider the tense, the voice, and conciseness before you make your decision. You can pause the video here and do the task. Now I want you to do another task. I want you to look at the excerpt provided and answer the following questions. Are the figure, captions and table titles placed in conventional places? Do the authors add titles to their figures? If so, where are those titles placed? Are there any dangling graphics in these excerpts? And if so, you may need to explain what you can see there. Moving on, we will talk about the discussion section in a poster. As you can see, we have 2 moves here. Move 1, interpret or explain your results, is often integrated into the poster results section, thereby becoming a combined results and discussion section. Um, Now, in this way, they do this because space is conserved and viewers can read and interpret the data simultaneously, which makes sense. For instructional purposes, however, um, you will see that move 1 is in the discussion section. We use a standalone discussion section in this hypothetical paper. So, move 2 ends with a take-home message. The take-home message sums up the essential conclusions of the presented work. Those points you most want your viewers to remember. Because of its importance, Move 2 is often given a separate heading. For example, conclusions or key points. Most take-home messages are only a few sentences or bulleted items in length. Some authors also include brief remarks about work in progress or future work at the end of Move 2. And Move 2 is generally written for a broad audience and thereby completes the bottom of the hourglass. What you need to do here is to highlight in purple Move 1 in the discussion section and highlight in yellow Move 2. Let's talk a little bit about the conventions in the discussion section, which can be very similar with the previous two sections, but I will still go through them. When it comes to bulleted and numerical lists, yes, we do have a list form, but complete sentences are more common than fragments. And you need to remember that. Conclusions are usually set apart from the discussion section with a separate heading. When it comes to citations, citations may be included in a poster discussion section. Posters generally include a few citations and an abbreviated references section, and as you will see later on. When it comes to hedging words should be used to soften the interpretive remarks in posters. And you can see words like may, might, could, possibly, and so on. When it comes to verb tense, both tenses are used for the same reasons that we mentioned before. And when it comes to voice, we have both active and passive voice that are being used. Right, let's move on to the next section of the posters, which is the introduction section. The poster introduction is typically not written until you know the full and final content of your poster. The first move of the introduction focuses on the importance of the research area. It should be clear to your viewers after reading only the first few sentences of your introduction what your general research area is and why the area is important. Background information is shared largely for the purposes of establishing this importance and should be kept to a minimum. Importance is also commonly established by pointing out gaps in the field, work that has yet to be done, or problems that need to be resolved. In-text citations to essential works are often included, although in posters they're not often required. An abbreviated citation format may be used to conserve space. If citations are not included, you should still know what major works influenced your work in case someone asks you. The second move of the poster in the introduction previews the specific accomplishments of the work and is often given its own subheading. We often see it as research objectives or goals. The focus should be on research goals that have been achieved and are presented in the poster. Move 2 has a narrower focus than Move 1, hence the poster introduction follows the broad to narrow hourglass structure. With the organizational structure of the poster introduction in mind, let's examine the introduction sections of the excerpt that we have available. Read it again, based only on the information presented. Answer those 3 questions. What research area is addressed? Why is the area important? What specific accomplishments will the authors present in their posters? As for the poster's acknowledgement section, you should acknowledge funding agencies and any individuals who helped you in the work and who are not named as authors of your poster. If space permits, consider including a funding agency logo. A references section is needed if you cite others' works in your poster unless you inserted an abbreviated reference directly into the text. If you include citations in only one section of your poster, let's say the introduction, the references section can be placed at the end of that section. Otherwise, include the references at the end or bottom of your poster. Format the references with a citation format used in the poster. Number them in citation order if you use numerical citations, which is actually better for space. Have a look at the references that you can see here on the slide. The first one is for posters. The second one is for journal papers. And the third one is for highly abbreviated formats that may be used in posters if space is really, really limited and you need to do that. But anyway, what you need to remember is that formatting should be consistent for all entries. This is the final slide of the presentation, and that's why I feel like I have to say a few things about designing a poster. Although the focus of this slide seems to be on visual appeal, I feel like I have to say that you need to remember that a good-looking poster is not a substitute for good science. Viewers visit your poster to learn about your science, not the latest trends in graphic design. Before you choose the best poster layout, you need to read guidelines for the authors presenting a poster at the conference you're planning to attend. Most conferences offer a certain set of guidelines to poster session authors. Much of the advice will be the same. So I strongly encourage you to check the guidelines for your own specific conference. As for fonts and font size, fonts can enhance or detract from an effective poster. There are 2 very common categories of fonts that are used: serif and sans serif. Serif fonts have letters with large tags at the end of each straight line, but the lines in sans serif fonts end abruptly without tags. Serif fonts are considered more traditional, while sans serif fonts have a more modern look. Some more fonts that are commonly used by chemists are Times New Roman and Arial. In addition to font style, authors must also pay attention to the font size. The rule of thumb is that the text should be easy to read from a distance of at least 2 meters. One way to check this on your computer is to set your poster to 100% scale and literally step back and check it out. When it comes to color and artwork, please remember to limit yourself to maximum 3 colors. Use colors consistently throughout your poster. Use conservative colors for the majority of your poster, and save bright colors for accents and highlights. Remember to use color only to enhance your science. Colors should facilitate understanding and they should convey some kind of meaning. And so try to create a color code and use it consistently in your poster. As for the final version of your poster and polishing things off, when we write, the intentional repetition of some content is natural. This is particularly true when writing for general audiences who often benefit from having an idea expressed in several different ways. In posters, however, identical phrases or sentences are repeated unnecessarily in the work, often unintentionally. We call this redundancy or unnecessary repetition. During the final stages of writing, you must look for redundancies in your work and either alter the redundant phrases or delete them entirely. Thank you very much for listening, and I hope you enjoyed this presentation. See you next week.